cattle industry loses $1 billion a year to stress-induced degraded meats, chronic disease, and an over-reliance to antibiotics. But these problems, they're not separate. They share a common biological pathway, the vagus nerve. Across mammalian species, the vagus nerve controls inflammation, gut motility, stress response, and immune function. And vagus nerve stimulation isn't new. It's been FDA approved for epilepsy since 1997, but in cattle, no one's ever tried. You'd expect it to be harder for a 600-kilo animal, but it's actually simpler. The nerve trunk is a single-fused cable, the anatomy is larger and more accessible, and the procedure works under standing sedation. No operating theatre required.
Bova is a nerve cuff with 8 electrode sites and an implantable pulse generator. Polymer encapsulated, no titanium, designed for a 5-year implant life. 8 electrodes, because that's what our models show is the sweet spot for fascicle selective stimulation. The problem? There is 0 published data on the bovine vagus nerve. No fiber counts, no fascicle maps, so we had to build the data ourselves. Starting from the pig vagus morphometry, adapting it to bovine geometry, and running a full finite element simulation of our electrode array. What you're looking at is the first bovine vagus nerve stimulation simulation ever run. It shows we can selectively target the anti-inflammatory pathway while avoiding cardiac side effects. That's the therapeutic window, and we can hit it. So we know what to build. Now, here's how we take it to market.
We've covered the vision, now here's our roadmap to get there. We chatted with Dr. Ronald Tessman, a leading expert in cattle health. He informed us that bovine respiratory disease is the top health and economic factor facing U.S. feedlots today. This makes it the natural starting point for Bova.
First, we validate. We implant our nerve cuff in stressed post-transport cattle prone to BRD at a small scale, validating our simulation parameters against live biology. We continuously measure key biomarkers to prove the device stimulates the vagus nerve and modulates the inflammatory pathways relevant to BRD. Second, we scale. With validated parameters and proven device function, we file a CVM pre-submission and partner with a working feedlot to test under real operational conditions. The nerve cuff is built for research precision, not necessarily for large commercial scales. Long-term, we look to minimally invasive delivery, modeled on the stentrode, an endovascular approach that eliminates open surgery and reduces procedural cost.
Tessman helped validate our unit economics. He told us 3 things. Treatment runs $50 a head, there is no accurate internal measurement system in the industry today, and a device that can both sense and stimulate would be, in his words, tremendous. His willingness to pay is $30 a head today, double that with therapeutic proof. While Phase 1 gives us clean efficacy data, surgery is not commercially viable at feedlot processing speeds. After scaling to Phase 3 at 100,000 units, device cost comes in at $48 to $83 per head. We know the margin is tight, but the device is not the only business. At 100,000 cattle, we have a novel dataset licensable to billion-dollar businesses built on vagal stimulation. We're building the first ever closed-loop sense and stimulate system for feedlot cattle.
Our first experiment costs $5,000. We've already documented everything on our blog: the science, economics, simulations, and engineering. Scan this for the full report. We're just a couple steps away from fully validating our concept. Ask us anything. Thank you.